Hello viewers, welcome to my channel. Today we will discuss about multiplicity of infection, that is MOI. We also discuss about some mathematical problem on this topic. For CSR NET, ICMR NET, GET, the question related to this topic is very important. So stay tuned in this video. So first of all, we will discuss about what is multiplicity of infection. Multiplicity of infection means that the bacteriophage to cell ratio. It is also known as MOI. In microbiology, the ratio of agents, for example, phage, more generally virus or bacteria, to that infection target is referred to as multiplicity of infection or MOI. For example, when we are referring to a group of cells inoculated with virus particle, MOI is the ratio to the number of virus particle to the number of target cells present in a defined space. So we can represent the MOI, that is multiplicity of infection, as the number of virus particle divided by the number of target cells present in a defined space. Now we will solve some mathematical problems on this MOI. The first mathematical problem is like that. 0.1 ml alicot of bacteriophage stock having a concentration of 4 into 10 to the power 9 phage per ml is added to 0.5 ml of E. coli cell having a concentration of 2 into 10 to the power 8 cells per ml. Then what is the MOI? As we know that MOI is equal to total number of phage divided by total number of target cells in defined space. So at first we have to calculate the bacteriophage and total number of E. coli cells. Here it is mentioned that 0.1 ml of alicot bacteriophage stock having a concentration of 4 into 10 to the power 9 phage per ml. So the total number of bacteriophage here is 0.1 ml into 4 into 10 to the power 9 phage per ml. That is 4 into 10 to the power 8 phage. Whereas the total number of bacteria E. coli cells will be that here the concentration of E. coli cell is 2 into 10 to the power 8 cells per ml. And it is mentioned that 0.5 ml of E. coli cells having the concentration 2 into 10 to the power 8 cells per ml. So the total number of E. coli cell is 0.5 into 2 into 10 to the power 8 cells per ml. That is 1 into 10 to the power 8 cells. The MOI is then calculated as bacteriophage per cells. So MOI is equal to 4 into 10 to the power 8 phage divided by 1 into 10 to the power 8 cells. That is 4 phage per cells. The answer is 4 phage per cells. Next question. 0.25 ml of alicot of E. coli cultured having a concentration of 8 into 10 to the power 8 cells per ml is placed in the tube. What volume of bacteriophage stock having concentration of 2 into 10 to the power 9 phage per ml should be added to the cell sample to give MOI 0.5? So here it is mentioned that the alicot is of E. coli cell is 0.25 ml and the concentration of E. coli cell is 8 into 10 to the power 8 cells per ml. And we have to calculate the volume of the bacteriophage, and the stock having the concentration of the bacteriophage is 2 into 10 to the power 9 phage per ml. That should be the and the final MOI will be the 0.5. To solve this question, first we have to calculate the number of E. coli cells in 0.25 ml of alicot. That is 0.25 ml into 2 into 8 into 10 to the power 8 cells per ml. That is 2 into 10 to the power 8 cells per ml. Next, we have to calculate how many bacteriophage required for an MOI 0.5. When 2 into 10 to the power cells, 8 cells are used. So as we have to assume that P fudge is required for MOI 0.5 when 2 into 10 to the power 8 cells are used. And as we know that the MOI is equal to fudge divided by total number of fudge divided by total number of cells. Here fudge is P, total number of fudge is P. And total number of bacterial cells, E. coli cells is 2 into 10 to the power 8. That is equal to 0.5 fudge per cells. So here P is equal to 1 into 10 to the power 8 fudge. Next, here it is mentioned that the concentration of fudge is 2 into 10 to the power 9 fudge per ml. So 2 into 10 to the power 9 fudge is present in 1 ml volume. Then 1 into 10 to the power fudge present in 0.05 ml volume. So the what volume of bacteriophage? The volume will be 0.05 ml. So the answer will be 0.05 ml volume bacteriophage is added to the sample to give an MOI 0.5. Next question. This is the question from GATE Excel Microbiology 20. Here it is mentioned that 250 microliter of bacteriophage stock having concentration 8 into 10 to the power 8 fudge per ml is added to 500 microliter of E. coli culture containing 4 into 10 to the power 8 cells per ml. Then what will be the multiplicity of infection? So we know that the multiplicity of infection MOI is equal to total number of fudge divided by total number of bacterial cells in a defined space. So first we have to calculate the number of bacteriophage present in 250 microliter of stock. So it will be 2 into 10 to the power 8. And the number of E. coli cell present in 500 micromilliliter of culture is 5 into 4 into 10 to the power 8. That is 2 into 10 to the power 8. So the multiplicity of infection is fudge total number of bacteriophage divided by total number of cells, that is 1. So the answer will be 1. Now let's discuss about some important notes, and these important notes are very important, and some questions related to these important notes also come in various exam. The first point is that when the experiments required that each cell in the culture is infected, then high MOI is required. Whereas when multiple cycles of infection are needed, then low MOI is needed. Next point is like that when the MOI is low, the cells growing rapidly, the lytic growth is favored. So if the option comes that lytic growth is favored when MOI is low, MOI is high, MOI is medium, none of these, then the option will be lytic growth favors when MOI low. And when the MOI is high, cells growing slowly, lysogenic growth is favored. So lysogenic growth when favored when MOI is high. Okay. And when multiple cycles of infection are needed, then low MOI is needed. And another is that high MOI is required when the experiment required that each cell in the culture is infected. Each cell in the culture is infected, then high MOI is required. Okay. And lytic growth favored when MOI is low and cells growing rapidly. Whereas lysogenic growth is favored when MOI is high and cells growing slowly. Okay. So thank you. Please like, share and subscribe to this channel. Thank you.